Hello and welcome to the first chapter of our Class 10th Science series, Chemical Reactions and Equations. Life is chemistry. Every change we see around us, from cooking meals to the simplest action of breathing, is governed by the laws of chemistry. We have already covered physical and chemical changes of matter in our previous classes. We have also studied that some changes could be both physical and chemical change simultaneously, such as the burning of a candle. Every chemical change can be represented by a chemical reaction. But first, let's study what is a chemical reaction. When we say a chemical reaction, we talk of chemical bonds which are broken within the reactant molecules, accompanied by the formation of new bonds. As a result, new substances are formed as products. To understand this further, let's take an example of a burning magnesium ribbon. When we lit a magnesium strip on fire, we observe that it burns with a dazzling white flame and changes into a fine white powder. This powder is magnesium oxide, which is also used for medical purposes as it aids digestion. Here, the chemical reaction occurs between magnesium and oxygen. Thus, we can conclude that a chemical change has occurred if we observe change in state, change in color, evolution of a gas, and change in temperature. Since now we know that a chemical change is represented by a chemical reaction, we still need a convenient way to describe them. For this purpose, we use chemical equations. Taking the example we studied before, here is the word equation of that chemical reaction. A word equation simply shows the change of reactants to products, which are separated by an arrow with the reactants on the left-hand side and the products on the right-hand side. The arrowhead points towards the products and shows the direction of the reaction. But there is an even better way to write chemical equations by making use of the chemical formulae and symbols. Using this, our equation becomes Mg plus O2 reacts to give MgO. You might have noticed that the number of atoms of oxygen are lesser on the product side than on the reactant side, and may wonder if this equation is correct, since it seems to violate the law of conservation of mass. Well, you are partially right and partially wrong, as here comes the topic of balancing chemical equations. In our previous example, we saw that the number of atoms of each element were different on either side of the arrow. Such an equation is called an unbalanced equation or a skeletal chemical equation. But this equation just gives an overview of the reactants and products. It does not tell the actual amount of each chemical compound involved. In the other case, if the number of atoms of each element are same on either side of the arrow, then the equation is called a balanced chemical equation. We can understand this better with the help of an interactive simulation. This simulation is a part of PhET-Sim simulation. We have our reactants on the left-hand side and products on the right-hand side. We first count the number of atoms of each element that are different on either side of the arrow in the chemical equation. Let's start with nitrogen. For one molecule of nitrogen, we have two atoms of nitrogen on the right-hand side. So we increase the number of ammonia, which is used as fertilizer in agriculture, to two molecules. Now, the nitrogen atoms are balanced, but the hydrogen atoms are still unbalanced. On the product side, we have 6 atoms of hydrogen, so we need 3 molecules of hydrogen on the reactant side. And finally, the number of atoms on each side are equal. But an important step is still remaining. In the final form of equation, we have to write the symbols of their physical states. So, a final equation looks like this. You can check out the remaining 2 examples in this simulation as well as practice many other examples on the EduRev app and website, which also provides detailed chapter notes and many previous year and NCERT questions along with its solutions to enhance your learning. Let's do a quick recap of this video. Firstly, we revised our concepts of physical and chemical changes. Next, we studied about the chemical reactions. And last but not the least, we learned how to balance the chemical equations. Thank you for watching this video, and in the next one, we will study the further topics of this chapter.